Today we're going to talk about the quotient rule. Obviously, if we have two different things getting multiplied or two different functions getting multiplied together, we can use the product rule. What happens when those two functions are being divided? And we want to be able to identify when to use the quotient rule and then effectively use it. The quotient rule says, just like I implied, if you've got a function that's equal to one function divided by another function, where you know how to do the derivative of u and you know how to do the derivative of v, but they're being divided, then the derivative of y is equal to the derivative of u times whatever v was minus u times the derivative of v. That sort of makes sense based on what we know about the product rule, but then that whole thing is divided by v squared, so there's that extra step. This is how it appears in your formula packet, or something very similar to that. I've also written it with the prime symbol, so the derivative of y is equal to the derivative of u, the numerator, times the denominator, minus the numerator times the derivative of the denominator, all divided by whatever was in the denominator squared. Right, example 1. I think you can try this on your own, since we've already done the product rule and this has a lot of similarities. Y is equal to x cubed divided by the quantity x squared minus 4. This problem should take about 5 or 6 minutes, especially since it's your first try. You can pause the video now. Alright, let's go through this one together. Y equals x cubed over x squared minus 4, so clearly my u is equal to x cubed. My u prime is equal to 3x squared. My v, which was in the denominator, is x squared minus 4. V prime is equal to 2x. Chain rule says that the derivative is going to be equal to the derivative of u times v minus u times the derivative of v all over v squared. So we'll make some substitutions. Y prime is equal to the derivative of u, so 3x squared, times v, which was x squared minus 4, minus u, which was x cubed, times 2x, which was our v prime, all over v, our original denominator, x squared minus 4, quantity squared. Now, the problem with the quotient rule is there's often a lot of things that you can do with it. Like at this point, we could distribute the 3x squared over here, and we could make it 3x to the 4th minus 12x squared. And then you could distribute here, we could have minus 2x to the 4th. Maybe then we could do some factoring after that. It's hard to know how far to keep going to. Really, these all end up turning into show that problems. On the IB test, they'll so often have a show that. They'll put it in a form, and they want you to do some manipulation to get it there. Maybe they're going to leave it just like this. Maybe they want you to clean it up a little bit further. The back of the book is the same way. They're going to have one version in the back of the book. Your goal is to see if you can get your answer to look like the one that's in the back of the book here. If we want to try cleaning this up just a little bit, like I said, we can distribute here, so we end up having 3x to the 4th minus 12x squared minus 2x to the 4th all over x squared minus 4 quantity squared. There's some like terms here, so I could rewrite 3x to the 4th minus 2x to the 4th as just x to the 4th. We had, x to the 4th. We had 3 of those x to the 4th. We took away 2 of them. And then minus 12x squared all over x squared minus 4 quantity squared. Some people might be happy with it there. Others might say, well, you could factor that numerator, and so we could rewrite that as x squared, because both of these contain an x squared, times the quantity x squared minus 12, all over x squared minus 4, quantity squared. Is that good enough? I suppose so. We're pretty well factored in both the numerator and the denominator. So you just kind of have to look to what the answer is going to be. If all we want to do is get the slope, we could have been plugging in values all the way back here, but if we want it to be about the cleanest we can possibly make it, somewhere around here would be that. Let's take a look at example 2. We've got the equation y equals x squared plus 1 divided by the quantity 2x minus 5. Find the derivative. Let's take about 5 or 6 minutes now. You can pause the video. Alright, let's go over this one together. Begin by labeling our u's. We've got x squared plus 1, u prime is going to be 2x. V is going to be 2x minus 5. V prime is going to be equal to 2. I like this one so far. Alright. We know that the derivative is going to be equal to the derivative of u times v minus u times the derivative of v all over v squared. Let's start doing some substitution. We've got u prime, which is 2x, times v, which is 2x minus 5, minus our u, which is x squared plus 1, times our v prime, which is 2. I wish I'd left some space. I could have put the 2 in front there, but now we divide it by v squared. And v is 2x minus 5. Square that as such. I think once again we're probably going to want to do some distributing and clean up that numerator. So 2x times 2x gives me 4x squared in the numerator, minus 10x minus the 2 times x squared will be negative 2x squared, and then that minus the 2 times the 1 will be minus 2 all over the quantity 2x minus 5 quantity squared. We can combine terms. 4x squared minus 2x squared leaves me with 2x squared minus 10x minus 2 all over 2x minus 5 quantity squared. You'll notice here in the numerator every one of those terms has a 2 in them, so we could factor out a 2, and you could have x squared minus 5x minus 1 all over quantity 2x minus 5 squared. And again, as you'll see on the worksheet today, most of either show that problems. It'll tell you what it wants to look like. Maybe that was good enough, maybe that was good enough, maybe we could have stopped all the way back here. And if your only goal is to find the slope, we could have plugged in a value as early as right here if we knew what x we were looking for, though it might have been easier to get to this point because there were a lot fewer x's to have to plug in and a lot less simplifying to do. And that is the quotient rule. Our assignment's on page 371. Numbers 1, 2, and 4.